Today my topic is on Internet of Things for Smart Cities. The outlines are introduction, smart cities, service specification for the smart city, urban IoT, smart city service health of public buildings, smart city service traffic consequences energy consumption, urban IoT architecture, web service approach for IoT architecture, application transport layer, 6 LOWPAN, device blanket server, gateways, IoT nodes, urban IoT network, smart city case study, smart city implementation. First is the introduction. The IoT is the recent communication that is a near further in which the object of everyday life will be equipped with microcontrollers, transceivers for digital communication and suitable protocol stack that will make them able to communicate with each other. Therefore, by enabling easy access and interaction with a wide variety of devices such as for instant home appliances, surveillance cameras, sensors, actuators, display, vehicles, and so on. It also makes the better use of infrastructure and keep the citizens safe and clean. What is a smart city? It is the in this the smart city most advanced communication technologies are used. It supports added value service for the administration of the city and citizens. It uses of IoT to manage of public affairs and make better use of public resource, increase the quality of service afforded to citizens, and enforce law eh, econ- encompass smart governance, mobility, utilities, building environment. Then next is the service specification for the smart city. There are different types of service over here, like structural health, waste management, air quality monitoring, noise monitoring, traffic conjugation, city consumption, smart parking, smart lighting, etc. And there networks, traffic rates, tolerable delay, energy source, and feasibility are informed. The next is the urban IoT. And this, the communication infrastructure provides access to services such as transport, parking, lighting, surveillance, maintenance, garbage collection, school, hospital. Open data can also be increased government transparency, participation and creations of the new services are also there. The next is the smart city service health of a public building. First is the buildings. In the database of the historical public buildings and their structural integrity, vibration, deformation, temperature, humidity, air quality, etc. are there. Then next is the waste management. In this, the waste management intelligent waste containers RFID to track trucks. It is also having the economical and geological benefits, and it also have improved the quality of the recycling. The next is the air quality. In this, it will monitor air quality in the public trails, open areas, charge companies for the greenhouse gas, and the population will also will get controlled. The next is the noise monitoring. It will also monitor the noise to it is the service to enforce the noise ordinance at the night. The next is the smart city service traffic configuration energy consumption. In this, GPS in smart vehicles air quality sensor. It helps the citizen plan routes and city to send the traffic officers. The next is the energy consumption integration with city power grid to monitor energy are used. It can also be purchased of energy through smart contracts. Then next is the smart parking. Sensors can direct monitors to open parking spots, RFID and FC to verify parking permits, handicap spots fine. The next is the smart lighting. It optimizes the street lighting based on the time, weather, and presence of the people. The next is the urban IoT architecture. In the urban IoT architecture, it is a centralized architecture where a dense set of devices generating data and delivered to the center of storage and processing. The heterogeneous technology must be integrated with the existing communication protocols. It makes data easily accessible to authorities and citizens of maximum benefits. The next is the web service approach for the IoT architecture. It has unconstrained and constrained. In unconstrained, the HTML and XML, HTTP and TCP, IPv4 and IPv6 are there. And in constrained, EXI, COAP, UDP, IPv6, and 6LOWPAN are used. And three layers are there that are data, application transport, and network layers are there. The next is the application transport layer. That is the COAP, less humanly readable, it is less complex than HTTP. It supports the all HTTP methods. It supports multicast transmitting data to multiple destinations. For the use, it uses UDP instead of TCP. HTTP and COP intermediate can translate the request. The next is the 6LOWPAN, that is in this the Open IoT compressed format for IPv6 and UDP headers over constrained network. It is based on IEEE standards. It has a large address space of IPv6, introduced too much overhead. It has the fragments and reassembles packets. It supports the it supports 127 bytes. It also supports the mesh routing. The next is device blanket service gateway IoT nodes. In this roots of the system, we find the packet service located in the control center where data are collected, stored, and processed to produce added value services. The packet services are not mandatory for an IoT system to properly operate through them become a fundamental component. A packet system commonly considered for interfacing with IoT data feeders. There are also low-cost sensors used. Mobile devices are also used. Protocol translation from constrained to unconstrained is also there. Then next is the urban IoT network as shown in the figure. The next is the smart city study. Smart city study case. In this case, we have seen that how the experimental wireless sensors network with 300 plus nodes were used. Different collection of environmental data were also used. Battery powered sensors for of the carbon dioxide, temperature, humidity, noise, etc. They also have used monitoring public street lighting. Photometer sensors measure the lightning intensity. Then smart city implementation. It describes in the hardware and software components of the system. The smart city components are street light. In the each street light is geographical localized on the city map. The monitoring of the correct operation of the bulb is performed through the photometers of the sensors, constraint link layer technology. The IoT nodes mounted on the streetlight poles from 6 LOWPN clouds using IEEE 802.15.4 constraint link layers technology. Gateway. The next is the gateway. It has the role of interfacing the constraint link layer technology used in the sensor cloud with traditional WAN technologies. The next is database servers. Database servers collects the state of the source that needs to be monitored in time by communicating with the HTTP COAP proxy servers. Operation mobile device. In the operation mobile device, public lightning operators will be equipped with the mobile device that can locate the street lights that requires inter- interpretation directly to IoT nodes connected to the lamps. Connected to the lamps. Thank you.